Introduction of electronics. Certainly. Let's dive deeper into some key concepts in electronics. 1. Electricity. Electricity is the flow of electric charge. It is measured in units of current called amperes. A, the movement of electrons through a conductor, such as a wire, creates an electric current. Voltage, V, represents the electric potential difference that drives the current, and resistance, R, determines the opposition to the flow of current. 2. Components. Resistors. Resistors are passive components that resist the flow of current. They are used to control current, voltage, and signal levels within a circuit. Capacitors. Capacitors store electrical charge and release it when needed. They are commonly used for energy storage, filtering, and coupling in electronic circuits. Inductors. Inductors store energy in a magnetic field when current flows through them. They are used in applications involving magnetic fields such as inductance, based filters, or transformers. Diodes. Diodes are electronic components that allow current to flow in only one direction. They are crucial for rectification, converting AC to DC, signal demodulation, and protection against reverse voltage. Transistors. Transistors are semiconductor devices that amplify or switch electronic signals and are the building blocks of modern electronic systems. They come in various types such as bipolar junction transistors and field effect transistors and field effect transistors. Integrated circuits, ICs. Integrated circuits are miniaturized electronic circuits consisting of interconnected components, transistors, resistors, capacitors, etc., fabricated on a semiconductor substrate. They provide complex functionality in a compact form and are used in nearly all modern electronic devices. 3. Circuits. Series circuits. In a series circuit, components are connected one after the other, forming a single path for current flow. The current remains the same throughout the circuit, while the voltage divides among the components. Parallel circuits. In a parallel circuit, components are connected across each other, providing multiple paths for current flow. The voltage across each component remains the same, while the total current divides among the branches. 4. Analog and digital. Analog electronics. Analog systems process and transmit continuous signals that can have an infinite number of values within a specific range. Examples include audio signals, temperature measurements, and voltage variations. Digital electronics. Digital systems use discrete signals that represent information using binary digits, bits, typically zeros and ones. Digital circuits operate with logic gates, which implement Boolean algebra and perform logical operations. 5. Basic laws. Ohm's law. Ohm's law. Ohm's law states that the current flowing through a conductor is directly proportional to the voltage across it and inversely proportional to its resistance. Kirchhoff's laws. Kirchhoff's laws are used to analyze complex circuits. Kirchhoff's current law states that the total current entering a node is equal to the total current leaving the node. Kirchhoff's voltage law states that the sum of voltage drops across all components in a closed loop is equal to the sum of the applied voltages in that loop. 6. Semiconductors. Semiconductors are materials with electrical conductivity between conductors and insulators. They are crucial for electronic devices. The behavior of semiconductors can be altered by adding impurities, a process called doping, to create either N-type, extra electrons, or P-type, missing electrons, regions forming diodes and transistors. 7. Microcontrollers. Microcontrollers are small computer chips that integrate a microprocessor, memory, and input-output peripherals on a single chip. They are used in embedded systems and control various devices and processes. Microcontrollers can be programmed to perform specific tasks and are commonly found in appliances, consumer electronics, automotive systems, and industrial applications. 8. Communication systems. Modulation and demodulation. Modulation is the process of encoding information onto a carrier signal to transmit it efficiently over a communication channel. Demodulation is the reverse process of extracting the original information from the modulated signal. Analog and digital communication. Analog communication involves the transmission of continuous analog signals, such as voice or radio signals. Digital communication involves the encoding of information into discrete digital signals, which are more immune to noise and interference. Communication protocols. Various protocols govern the exchange of data between electronic devices. Examples include Ethernet for computer networks, Bluetooth for wireless communication, and USB for connecting peripherals. 9. Power supply. Power sources. Electronic devices require a power source to operate. Common sources include batteries, Acme's power, or renewable energy sources like solar panels. Power ratings. Devices have power ratings specified in watts, W or kilowatts, Q, indicating the amount of power they consume or deliver. 10. Digital logic. Logic gates. Logic gates are electronic circuits that implement Boolean logic functions, and, or, not, etc. They process binary inputs and produce binary outputs based on specific truth tables. Combinational and sequential logic. Combinational logic circuits produce an output based solely on the present input values, while sequential logic circuits use memory elements, like flip-flops, to store information and produce outputs based on both present and past inputs, based on both present and past inputs. These topics provide a more detailed understanding of electronics. Exploring each area further will reveal additional concepts and applications, such as analog and digital signal processing, control systems, sensors, and actuators. It's a vast field with endless possibilities for learning and innovation. Thanks for watching.